So in this video, we're going to see the concept of equivalent forms of rational numbers. What does this term mean? Equivalent forms of rational numbers. So before proceeding, let's quickly note down what rational numbers are. We saw this definition in the previous video. Rational numbers are any numbers which are of the form p by q, okay, where p is any integer. Let me write it down. P is any integer and q is also any integer other than or except 0. We don't allow the integer 0 on the denominator of a fraction because division by 0 is undefined in mathematics. So this is our definition of a rational number. Now let's take an example of a rational number. Okay, so let me draw a line here. So let's consider one example of a rational number. For example, let's consider 1 by 5. 1 by 5 is a valid rational number. Yes, because it fits into this definition of p by q. Now what I'm going to do is I'm going to convert this 1 by 5. Okay, I'm going to convert this 1 by 5 by multiplying by 10 to both the numerator and the denominator. Both numerator and denominator will be multiplied by this number 10. So what am I going to get? I'm going to get 10 by 50. Okay, so I have converted this one rational number into another form of rational number. This is also a valid rational number. 10 by 50 fits into the definition of p by q. So one rational number is converted into another form of rational number and both of them are equal. Okay, so this is the equivalent form of a rational number. Okay, so 10 by 50 is an equivalent form of rational number 1 by 5. Okay, we can do the same thing by using some another multiplicative number. For example, let's consider here 1 by 5 again. So I'm going to write here 1 by 5 and now I'm going to multiply both the numerator and denominator by, let's say, 3. Okay, so what I'm going to get is 3 divided by 5 into 3, 15. In fact, we can continue. Let's multiply this by 5. Okay, so what I'm going to get by multiplying 5 is 3 into 5 is going to give me 15. I'm going to write here 15, and 15 into 5 is going to give me 75. Okay, we can even continue further. Let's multiply both numerator and denominator by minus 2. Okay, let's multiply them by minus 2. So 15 into minus 2 is going to give me minus 30, and 75 into minus 2 is going to give me minus 150. Okay, thus note down, thus 3 by 15, okay, and 15 by 75 and minus 30 by 150 are all equivalent forms of 1 by 5. Okay, so this is the concept of equivalent forms of rational number. All these rational numbers are equal to each other. They are equivalent to each other, just represented in different forms. So the important concept or the important idea is that, which I'm going to write it down here, that there is no unique representation of a rational number. There is no unique representation of rational numbers. This is the important concept. Rational numbers do not have any unique representation. If you consider other number systems, whole numbers, integers, or even natural numbers, they have a unique representation. But rational numbers, they do not have a unique representation. They have all these different equivalent forms of rational numbers. So this is an important concept which we'll be using several times in solving a lot of problems from the exercise.